Welcome to Math Calendar. Today, let us show the solution to our featured problem for week 1. But before that, let us recognize those who participated in week 1 of our Math Calendar. This time, let us solve this problem. How many odd positive integers are factors of 480? Let us start by writing the prime factorization of 480. And we can do that by using the continuous division method. So let us divide 480 by prime numbers continuously. 480 divided by 2 is 240. Then 240 divided by 2 is 120. Next, 120 divided by 2 is 60. Next, 60 divided by 2 is 30. Still, 30 can be divided by 2. We have 15. Now, 15 can be divided by the next prime number, that is 3. And 15 divided by 3 is 5. Then we can write 480 as the product of its prime factors, that is 2 used 5 times as a factor, so that we have 2 raised to 5 times 3 times 5. Notice that the prime numbers 3 and 5 are used once as a factor in the prime factorization of 480. Therefore, the number of odd positive integers divisor of 480 is equal to the exponent of 3, that is 1, 1 plus 1, and the exponent of 5, that is 1, so we have 1 plus 1. Therefore, we have 4 odd positive integer factors of 480. Since 480 is quite a small number, we can get the answer to this problem by listing method. We know that 1 is a factor of 480. Also, 3 is a factor of 480. 480 ends with 0, then 5 is also a factor of 480. We know also that if a number is divisible by two different prime numbers, then it is divisible by the product of those two numbers. Since 480 is divisible by 3 and 5, 480 can also be divided by 3 times 5, and that is 15. So using the listing method, we have 4 odd positive integers that are factors of 480. Now, what if we have bigger number than 480? Let us recall the rules in finding the numbers of divisors of any number. The number of divisors for any integer n greater than 1, writing the prime factorization of n as p sub 1 raised to a times p sub 2 raised to b times p sub 3 raised to c, and the pattern continues until p sub k raised to m, where p sub 1, p sub 2, p sub 3 until p sub k are prime numbers, and a, b, c until m are positive integers, then the number of divisors of n can be found using the formula d of n, that is divisors of n, is equal to a plus 1 times b plus 1 times c plus 1, and the pattern continues until m plus 1. That is the product of 1 more than the exponent of all the prime factors of n. How about the number of even divisors and number of odd divisors for any integer n? Let n be equal to 2 raised to t times p sub 1 raised to a times p sub 2 raised to b times p sub 3 raised to c. The pattern continues until p sub k raised to m. In here, p sub 1, p sub 2, p sub 3 until p sub k are prime numbers other than 2. And t, a, b, c until m are positive integers. Then we have, if t is equal to 0, that is the exponent of 2, then there is no even divisor. That is, if 2 is not a prime number factor of n. If t is equal to 1, then the number of even divisors is given by d of n is equal to a plus 1 times b plus 1 times c plus 1, and the pattern continues until m plus 1. Now, if t is greater than 1, then the number of even divisor is d of n is equal to t times a plus 1 times b plus 1 times c plus 1, and the pattern continues until m plus 1. Now we get the number of odd divisor, that is given by d of n is equal to a plus 1 times b plus 1 times c plus 1, and the pattern continues until m plus 1. The same formula that we used in finding the number of positive odd divisors of 480. That will be all for our featured problem in week 1 of our math calendar. You can also suggest a math problem if you want it to be featured in our math calendar. Please tune in to our math calendar on Sunday, January 10 for our next featured problem. Thank you for watching. Please subscribe for more of math calendar.